organization that has a number of different divisions and practices, but we're around 270,000 employees now with the addition of Altran, which was a big deal for us. And what we like to think about and help our clients do is go from ideas to solutions. And those solutions are physical or digital or some innovative combination of both. So, you know, that's my background is a little bit more from the innovation and digital agency, business consultative standpoints, but a lot of our bread and butter is around traditional systems integration. So with that, I'm gonna just take a look at a couple of stories from the news recently. These are not exactly pulled for any reason other than I think they really represent a direction that we're going in, and some directions that I'm very excited about. One of which is EVs and the need to put a charging infrastructure in place that is commensurate to the demand that we're expecting to have. And where is that demand coming from and how are we going to get there? Well, you may have heard recently that the governor of California said that they were not going to have any more gas-powered cars by 2035. And, you know, sometimes that seems like a long way away, but it's really actually not. It's kind of right around the corner when you think of the massive amount of infrastructure and change that is going to happen to be able to support that kind of market shift. So that's California, but it's happening all over the country. And, you know, you have big networks like Tesla's network and Charging America. But there's still a long way to go. And so there's a lot of planning, there's a lot of money being invested in it, and there's a lot of activity that I think is just a really exciting space. Piggybacking slightly on that charging network and talking about really exciting spaces, I'm a big blockchain fan, and it seems like every October, every 3 years, every October, it's all blockchain all the time. So here we are again. And for those of you that may not be quite as familiar with blockchain, it's just a distributed ledger technology that can be verified by anybody. So it's an open source ledger, transparent, but it's also really good at a couple of things like being particular about very low-level details and making those low-level details happen quickly in a structured manner, and even carrying a payload of a payment to process that, so that everybody gets paid along the way. So as it turns out, that works out pretty well for a couple of use cases in the automotive space, one of them being management of the grid and the vehicle charging. So that's kind of an exciting thing. You know, speaking of vehicles and electric startups, how could we go any further? We couldn't. I'll answer my own question. Couldn't go any further without talking about Rivian. They are a super exciting company. If anybody was at CES earlier this year, you might have seen the Rivian truck, beautiful truck, parked in the Amazon display booth. It was so crowded around that truck, I could not get a real picture of it, and I'm short, so that didn't help anything. But it was just a fantastic looking truck. Now, of course, you know, they've got strategic investments from Amazon and closer to my home. I'm based in Atlanta, Cox Enterprises, and they're you know, doing electric trucks, but they're also doing last mile vans, delivery vans. And the thing about these is it's not just an electric van, it's a high tech, you know, sensing device that's going to have all kinds of really cool driver assisted systems, you know, approaching those autonomy levels where it's going to really be interesting. And they're going in market in a significant way at scale. So super excited to be looking at and thinking about those. And hopefully we've got some Rivian team members in the audience, and maybe we can have a little dialogue about how things are going and what to expect next. As we think about the Internet of Things, as I'm sure this group spends a lot of time doing, um, just the scale and the volume of that activity, the number of devices, the kind of communication that's going to be coming in and around and through those devices, really is going to be hard to get your hands around. And so, a lot of people are talking about the need for layering on artificial intelligence to manage many aspects of the Internet of Things. And this Gartner thing, the reason why I put it in here, this Gartner report states that by the year 2022, not that far away, 80% of enterprises will have both some combination of AI and IoT deployed, which seems like a crazy high number, but I think it just goes to show you that things are happening very fast. And the world of autonomy is changing super fast, and we can talk about that a little bit later in some of Scott's slides as well. And then last but not least, that autonomy is coming right here to friends of ours at Caterpillar, where I think, now if I read this right, and you guys correct me if I'm wrong, what I saw was that there was going to be remote control or autonomous technology deployed on work sites by January. Short time away, right around the corner. So, that's a big development, and I think that you're going to see a lot of really interesting use cases for that remote operation and autonomous operation for large vehicles at construction sites and mining operations. So, all right, so just a potpourri of recent news stories. Where are we going with all that, and what does it mean? Well, I imagine that you guys have all seen this CASES model, right? We added an S at the end at Capgemini for sustainability. We are committed to being carbon neutral, and we place real value and importance on that. But my point is here, CASES has been a point of view and a direction that we've all been going towards, and has been kind of this future state idea. But my supposition to you today is the future is here right now. All of these things are here right now. Some more, some less. The sharing economy, this year with COVID took a little bit of a hit in terms of desired usage, but these things are all systems that are being put in place right now and around us, and so this is less of a cases, this is where we're transforming, to a cases, this is where we are, right? And the business opportunities are tremendous. From ecosystem partnerships, the last mile delivery, we work with so many clients that are focused on using autonomous vehicles, not as passenger vehicles, but as the delivery, the last mile delivery in an integrated supply chain. The connectivity and real-time insights, we think a lot about what 5G is going to do, and what it's going to enable all of our devices to do. Why high bandwidth, low latency is going to open up a world of possibilities. And so all of these things are happening right now. And another little quick Capgemini thing, Capgemini has really changed the focus or evolved our focus past cases to thinking about how an intelligent industry is going to run and operate. What are the processes, what are the operations, support, and services that are all powered by and enabled by data? So we believe, especially with the acquisition of Altran and all the smart engineers there, that we're one of the few companies, maybe a handful of companies globally that can really operate at scale, from the strategy all the way down to the assets and the engineering and the cloud networks in between that allow all those things to operate smoothly. So I think that there's a real exciting opportunity for us all to think about and talk about, and we're not going there, we're not going to get there, we're there right now. It's really started right now, and the projects that we're all working on, and I'm sure you guys are working on many very interesting projects, are integrating these things, and they're doing it in a way where they're blending together. So that's the kind of the idea behind this intelligent industry focus is, creating a zero distance, creating a sustainable industrial footprint that we can, be the future. We can see the future and make the future that we all want, both for ourselves, our customers, our employees, and the world around us. So that's a really exciting change that we've made this year, and I think it's in response to the convergence of all these enabling technologies and business models, and a real desire for people to pick these up and make really interesting, cool things out of them. So that's a little upfront part of our presentation. I'll pause for just a second. If anybody wants to shout out with a comment, a question, hey, how are you? Any of that? All good? So, yep.
I'm just the infrastructure that you're putting into place for the electric vehicles. I've heard the existing ones already. There's backlash from guys driving diesel trucks, and they'll park in front of them to prevent them from being used for charging. Is that something being considered as far as the?
Changing mindsets, I think, is one of the things that is more of a problem than sometimes we acknowledge, right? I mean, one of the biggest barriers to the adoption of blockchain technology is not the technology, although there are some significant barriers there. It's more of the mindset, the societal approach to sharing data, and yeah, just embracing these new modes of transportation or new supply chain characteristics. I've also heard of people parking their car in the electronic charger parking spaces, right? Because they were mad that they got those spaces, in a special place that are closer to the door. I'm old enough to remember before we had handicap parking, and when that came in, and everybody was like, "Oh, I don't," and it's just one of those things that I think, as people start to think about the benefits and the value of it and the shared benefits, that's going to get a little bit easier to sell in from a usage model or an acceptance model. I'd love to hear what anybody else thinks to that, if anybody has an opinion. Going once, going twice. All right.
David, Daniel, yeah. Sorry, I have a question. I mean, there's still a lot of people that are naysayers and don't like blockchain. How would you respond to some of the comments about that?
Sure, absolutely. And I really, I don't mean to slant this whole thing blockchain-y, so I promise not to be some zealot. But what I would say is the blockchain technology is about technology, but it's also about that cultural adoption. And it took a while for the internet to really get some traction, right? I mean, if when I was first selling websites, I would ask in the room for anybody that had an email address to raise their hand, right? So it was early, and people didn't trust things. There was a reticence, certainly, to put your credit card, right, into an e-commerce system on a website on the internet. And I think that resistance over time decreased because the value of that in benefit was so great. So I just think to yourself, what was the first thing that you bought online? When you actually put your credit card in there? I bought a book, right? And maybe many of us bought something on Amazon, and it was a little bit of I'm not sure about this. I think that the kind of the value in blockchain is that there's no need for that central authority, so that we have this trustless environment, decentralized environment, much like the internet was in the beginning, a decentralized information system. And I think that you're going to see over time that there are many benefits to that, especially just for one use case, when you talk about supply chains and the complexity of supply chains, one of the topics there is supply chain mapping. And you know how incredibly difficult it is to map a supply chain past one or two hops, because you just don't have the information that runs end to end. If you had a consortium approach using a blockchain or distributed ledger technology, be it public or private, you would be able to have much more traceability through that whole supply chain map, supply chain end to end, and thus be able to map it with a greater fidelity. So, you know, maybe that answered your question, maybe it didn't, but I'd certainly, I can talk about blockchain all night, so we probably don't want to do that.
Great, thanks.
Sure.
Hey, Daniel, are you seeing an acceleration because of COVID with the more people adopting the technology?
I think that acceleration is the key trend that we've seen from this crisis, from the pandemic. It's accelerated so many aspects of our digital adoption, certainly. And I think it's given us a real push towards some things around autonomy, some of the electrification of our vehicles, because all of this has really put the pedal to the metal on e-commerce, right? The numbers for e-commerce have gone bonkers, and it's not just Amazon. The number of people that are shopping for groceries, that are having things delivered, I mean, that whole segment was there, but it wasn't a huge part of the equation. You know, I think that I saw that still e-commerce only accounts for 30% of the overall commerce register rings right now. And that number is doubled this year. And somebody please correct me, because I'm sure I got that wrong. But the point is, e-commerce and last mile delivery are a huge area of interest for consumers and producers, and the logistics providers that enable all of that to happen. So yeah, acceleration is, and then also think about what we're doing right now. Right? The idea that we would all work from home and do Zoom meetings and still, you know, and everything wouldn't fall apart. I mean, I don't know if who would have believed that in January if you said, okay, listen, I tell you what, everybody go home, right? We're going to do all this virtually. We're going to do these meetings remotely. We're going to have a meetup, and there's somebody from Atlanta is going to present, and somebody from Ireland is going to dial in, and we're all going to have this great event. I don't know. There might have been some doubters, right? There might have been some naysayers, but here we are, and we're doing it, and we're going to figure out how to do it and how to do it well. And I think we're going to all be better for it. I think that just again the sustainability aspect of not shipping atoms if you don't have to is pretty compelling, right? Ship the digital part, not the physical part, if you can. Yes, let's do some use cases.
Perfect.
Hey, Scott Runner, are you out there? Oh boy, his slides are going to get the light treatment tonight. All right, so we're going to.
I reached out to Scott. He's not. I don't know what happened to him. I know he was going to join, so I don't know what happened to him.
Well, that's all right, and it's not all right for you guys, because you're really going to miss a dynamic speaker and a guy that's a whole lot smarter than I am. But we'll just we'll make the best of it, shall we? So, in the attempt to make the best of it, we think and talk a lot about what we call V to X. Everybody calls V to X, vehicle to anything, right? So V to V, V to I. It's really the idea of these of anything that's moving, talking to anything and everything else. And so when you're thinking about stuff that combines so many different aspects of the technology frameworks that we're all kind of thinking about and working with, it's a compelling issue to pick the right case and to find the right execution that's really going to provide value and a return on the investment and value to everybody in the ecosystem. So one of the things that a lot of people talk about in that is the monetization of data that gets thrown off of those systems. We recently released a report on data monetization. Just a quick plug for the Capgemini Research Institute. Those folks do really good work, really compelling work, global surveys, really fascinating studies. We just released our trend radar on connected vehicles in September, followed it up with this monetization report. So go click around to find those. I think you'll find them to be worth your time to give a read to. So I'm just going to do a couple of highlights from this report. We found that a lot of people are making investments in connected vehicles, but a lot of those investments fall short. And the thing that I think jumps out at me on this slide is that 80% of these services, products, whatever features remain in pilot stage, never make it out of pilot stage. That's a pretty common problem that we've seen. And so some of the things that we've done is we tried to figure out ways to address that. And I'm not gonna talk this one, but really what you want to do is try and figure out how to jump through that validation and testing to scale and run, because otherwise these are just kind of lab projects that are, you know, maybe pet projects or something, but don't have the opportunity to really break through and add value to the organization. So we've done some thinking about how that works, and we've also done some use case prioritization where you can see, you know, obviously top right corner, there's all the good stuff up there. One of the things that I spend a lot of time talking about is the smart keys, and we've seen some number of smart key initiatives start to take off, and I think again, if you think about how you can track those, I got a cat coming in. We'll see if the cat makes it in the screen. If you think about tracking those smart key capabilities and then being able to use those for fleet management or you know, ride sharing or car sharing, that's just one of the most I think straightforward ways to think about how all of this IoT stuff is really going to work itself into, okay, here we go, here's a cat. It's a big trophy cat right here. What? Okay, no more cat. But you know, we've got a lot of the use cases in that report, and invite you to go take a look at it and think about how these things could work into your programs, into your roadmaps, and where they may be able to actually add value. And so just a quick little example of that, we've been working with a fleet provider doing a lot of work, and you know, what we found is there was some real opportunities to do some platform modernization. The DevOps around this stuff is super important, and as you think about monetizing your fleets or your assets, you know, there's a couple of different levels of that. You know, you can monetize it by being able to provide your employees better information and more targeted information in a customer service framework. You know, resolve issues faster, resolve issues better. You could think about providing that data through to the end customer, right? Either as a value add or as a potentially a paid product to improve their ability to use your products and your services and your systems. And then finally, you could think about kind of providing that data in a data broker marketplace where it gets anonymized. I do this every time. And we've recently formed a strategic partnership with a company called Autonomy that does just that. They've unlocked a lot of this telematics data working directly with OEMs to then ingest that, normalize it, and autonomize it so that they can sell it in a third-party marketplace. And the buyers for that are still it's still early. It's still an early marketplace, but you know, these are data sets and capabilities that are going to be hugely important over time, especially as we think about autonomy and as we think about, you know, supervised learning and the bottlenecks around annotation for supervised learning and needing to do unsupervised learning over huge data sets. You know, how are you going to get those huge data sets? That's one way to do it, right? So there we go. We're going to talk a little bit about the mobile communications part of V2X, and anybody that wants to jump in and talk, please do. I'm sure you guys are getting.
Hey, Daniel and Shannon, Scott's trying to join. Can you let him in?
Oh yeah.
Admitted him.
Perfect.
Fantastic. Right on cue.
Scott is right on cue. Perfect timing, Scott.
As if it was planned that way.
It was planned that way. Hey,
That's right.
Scott, how's it going?
It's going well.
Okay.
Hey, Dan. Hi, everybody.
You've got a warm audience that are ready to hear about V2X use cases and mobile communications. So, slide.
Absolutely.
And it's cat day, and Daniel showed his cat. So
I did.
If you got a cat nearby, you may want to show it on screen, Scott.
Actually, I do have 2 cats, but they're downstairs right now waiting on food.
I think that's why my cat is so interested in me right now.
Mine's always by the fridge waiting to eat.
Yeah, it's funny how we've gotten to know all of each other's pets and family members in this time of COVID, and yeah, it's kind of interesting. Well, good. Well, listen, I'm Scott Runner. Nice to meet you all. I think you've already made the round of introductions. I lead Alltrans global service line around automotive, electrical, and electronics services. So one of the things that we've realized in this emerging world of connected mobility services is we're starting to pull together different pieces of technology from other industries that historically weren't necessarily related to transportation. And so I think in the remaining use cases that we're going to talk about, you'll see emphasis of that, of which kind of technologies come to bear. And many of these are not traditional transportation types of technologies. So first, we're going to start off with the concept that the vehicle is a platform for connected mobility services. Back in the early 2000s, I had the honor of working on the first team at Qualcomm that worked on smartphone chips for the initial Apple iPhones and the initial Android phones. And at that time, that was, of course, the mobility platform. And we see all of the different use cases that emerged from that platform. When we developed that, we never had the notion of something like Uber coming along or Airbnb or any of these other types of services. We certainly didn't envision at the time that people might actually use navigation on their phone in the car before they would use the car's own navigation system. And so we see now, obviously, the transportation is emerging as the next mobility platform, and that taking all forms from consumer to commercial to industrial, mining, and other interesting applications of transportation. So what we see coming off of the vehicle as a platform is that the original classes of use cases that emerged for V2X or vehicle to everything were initially largely focused around safety. They were also focused around maintenance and upgrades. But now we see a much broader space of use case classifications emerging around sustainability, for example, and we're going to talk a bit more about that later. But you know, how we can use connected vehicles to actually improve CO2 footprints and energy efficiency overall. Also as a platform for e-commerce, and we're going to talk about that a little bit more. I think Dan's talked to you a bit about data monetization, and that's really key to the e-commerce aspect of things. And then certainly making our lives more convenient, giving the user journey or the user experience from the time you wake up to the time you go to bed more seamless as it integrates into mobility and the different places and experiences that you connect into, you know, at that point where we can actually get out of our homes. And then, of course, you know, entertainment, improving entertainment experiences using, for example, even every window in the car is a potential display to enrich potential entertainment as the car starts to maybe move towards maybe kind of a mobile living room or a mobile office. So some specific application examples that we've done with clients, like the ones you see up at the top, are location-based services for EV charging and route planning. So all of us know about, obviously, you know, using a route, you know, navigation tool or route planning and connecting to nearest EV charging stations. But what about also using information about the battery charge, the road terrain, you know, the typical speeds that we tend to drive and things like that, to actually, you know, use that battery state information in our preferences and things like that, and where we might want to stop to eat or things like that to do better route planning even for EVs. That can be even carried over into commercial vehicles. Also, audio and video streaming entertainment services. Obviously, streaming has become kind of a key way of gaining our entertainment. How do we do that with seamless connectivity and you know, cost effectively and with rich experiences in the vehicle? And then also using this mobility platform as a marketplace to enable third-party application developments. Just like when we developed the first smartphone, we didn't envision Uber. There's many more applications out there that we have not yet thought of. So, you know, all of us are smarter than any one person or company together. So how can we open up an ecosystem to enable that kind of innovation? So that's a bit about the platform itself. What about the use cases themselves? I mentioned these different technology combinations, and how could one potentially come up with a framework that helps ideate about future possibilities of use cases? Well, one way to do this, of course, is to kind of work top down in terms of what types of problems, what types of opportunities, you know, that you're trying to solve, and work backwards. But another way is obviously to kind of see, well, what kinds of use case dimensions do I then wish to tackle? And then from that, what kinds of technologies might I employ in order to do that? I think today, many of discussions that we see are kind of a tool looking, or, you know, the hammer looking for a nail kinds of problems. And what we're trying to do is to say, you know, V2X, for example, or, you know, 5G, these are all great technologies, but let's use those as tools in a toolbox to solve problems. And so over on the left-hand side, we might see, like I mentioned, early use cases around safety. This would be kind of vehicle-to-vehicle types of cases, or vehicle-to-infrastructure cases to improve safety. There's a goal in Europe of course, to try and get to 0 fatalities by 2035, you know, using the V2X types of technology. Another aspect, of course, though, might be smart city related use cases where, you know, we're looking for how do vehicles interact with the city. And we'll give you an example coming up here specifically of how, you know, that could work, you know, more effectively. Another interesting class of them is Industry 4.0. So how do, you know, commercial vehicles, you know, navigate loading and unloading around warehouses or in a factory? You know, how do we manage autonomous equipment, autonomous forklifts more effectively? It uses some of the same underlying technologies as some of these other use case classifications. You know, connected delivery, that last mile delivery problem, be it through drones or be it through some other autonomous vehicles. We'll show an example. You know, connected delivery is a classification. So really, I'm not going to go through all of these in the interest of time, but I think you get the idea. You can start to say, for my particular objectives, what classes of problems do I want to solve? And then on the right-hand side, you start to look at what technology combinations are required in order to consummate those particular types of use cases. So one example I'll give you is, many people felt like, the V2X technology, be it cellular or direct short-range radio, was going to require national mandates in different countries. And so a lot of people were blocking on that. But then they started to realize, well, actually through cellular or even satellite technologies, I could actually accomplish quite a number of these use case categories on the left-hand side. I don't necessarily need cellular V2X to be deployed nationwide in order to achieve, a number of these use cases. But there's other kind of differentiating technologies that are starting to come into play. For example, the combination of 5G or V2X with edge compute and how that solves the smart city problem. And so as you can see, you're starting to kind of combine pieces of this. All of this at the end of the day starts to look a lot like, this thing on the right of IoT, right? Where you sense, communicate, compute. And from that point of view, of course, as Dan was talking about, data and data science becomes important. Communications becomes important, and computation, becomes important. So this is just kind of a framework in terms of looking at the types of use cases and the requisite technologies themselves. So getting more specific in terms of use cases themselves, as we start to look at platforms from vehicle through communications to cloud, we see kind of 6 different use case categories, if you will. One of them would be extensions of your traditional, and these connected mobility services, CMS, your traditional telematics. So we start to see location-based services, which would include fleet management, logistics. But now as we start to add other capabilities that we're sensing, additional sensing capabilities, we can start addressing cold chain and end-to-end. So maybe now, not only in transportation, from manufacturing to to warehouse, to store, to pharmacy, to store, et cetera, can I do cold chain? I could do actually monitoring for FDA regulatory monitoring purposes in Industry 4.0 in the manufacturing plant, then onto transport, and then into the consumer experience. So I actually have a cold chain that now extends much further and provides automated record keeping and things like that. So really we're talking about some of the traditional telematics use cases, but adding more data intelligence to them. Likewise, Predictivex, we've of course known about predictive maintenance for years. For example, we have a demonstration vehicle of predictive brake replacements for trucking. Any of these parts in a transportation environment or a manufacturing plant, of course, the idea is build an analytical model that stands up to experience, train it, and use that model with the objectives of trading off your mean time between failure with the cost of replacement and repair, and make sure that you're addressing both your quality and cost efficiency goals as much as possible. This notion that the part shows up obviously well before the machine ever fails or the vehicle ever fails. But you can also apply that same thing to things like predictive inspection for trucks on routes. You could apply this in the mine for obviously real-time data acquisition of drilling to optimize probabilities of where you're likely to find certain resources. Same thing with safety. To be able to merge IoT and transportation, to be able to predict unsafe potential events. There's even been talk about using, for example, on trucks, using IMUs and sensors in trucks as they pass across bridges to provide that data to the DOT to be able to provide information about the safety of bridges. I mean, there's just a really rich set of possibilities in this space. I'm going to kind of combine the 2 topics on CAV in this context is connected autonomous vehicles. I'm going to kind of combine these 2 together, but we certainly see that these autonomous vehicles, if you look at camera, LiDAR, radar, IMU data, they're generating between 5 and 20 terabytes per car per day. Now, most of that doesn't get propagated up to the cloud. It gets ingested and processed on the vehicle, but it's still a tremendous problem. So it's basically a data center on wheels that you're dealing with here. But how that gets applied to use cases, there's a number of things that you can obviously do. I mean, one of them is just simply at this stage of autonomous vehicles, improving the algorithms for autonomous vehicles to reduce rates of accidents. Refine these algorithms better and better. Also share information, have this notion of what's called cooperative perception. So multiple vehicles can share metadata and get an image of the road conditions around them, the driving conditions around them, and start to cooperate better to, again, provide greater safety and better, algorithms ultimately. Even we'll get into this a little bit more, a tuning of EVs, again, within the vehicle, tuning the optimization or the performance of the engine, but also providing that back to algorithm development back in the R&D facility so that engineers can improve their algorithms and then push through over-the-air updates, improvements of those algorithms out to the vehicles. So we certainly see this as a new and emerging, area for these use cases. And then the last two, I'll kind of merge these two together as well. I think Dan probably covered some of this a little bit already, but we certainly see the mobile platform, the smartphone on wheels, if you will, as creating a variety of new connected mobility service e-commerce experiences. And those could be at the form of, I'll give you an example on platooning. So one of the things in truck platooning that isn't being enabled now is the fact that not only could a commercial company that owns an entire fleet platoon that fleet for energy efficiency, but you could also have third-party truckers join a platoon and even join in a business model that kind of profits for all of those that are involved in that particular platoon. And that is something that is certainly occurring. Vehicle sharing and vehicle rentals, obviously, the next generation of Uber, will do this even more seamlessly as well with autonomous vehicles. Okay, so that's kind of the approach of giving you some examples of that. I'm only going to briefly touch on this slide, and I'm assuming we'll provide these slides to you for reference, but this was kind of related to strategies for monetizing connected vehicle use cases. So, if you were trying to look at, well, gee, first I want to start with a strategy for what can I do and what accomplishes my goals. There's some things that originally were going down the path of national mandates for optimization of fatalities. In Europe, there's some consideration of V2X now for CO2 optimization. But it doesn't necessarily have to require a national mandate. A particular smart city could choose to provide certain services that it enables, for transportation services in its cities and provides APIs for those types of services. Or a particular fleet, an OEM fleet might choose to do that. For example, if you look at VW has about 17% of the passenger vehicle fleet in Europe, and they've chosen to move forward with a V2X technology that has some synergistic benefits just for their fleet. And then, you see other applications. Another interesting one would be at the bottom, these targeted use cases where you have autonomous construction, mining, warehouses, and you're basically automating the transactions and activities for those particular use cases as well. Okay. All right. Touching on the specific topic of autonomous vehicles, let's delve into this a little bit more. One popular use case that's been emerging that a lot of people are working on, Tesla's working on this, a lot of people are working on this, is autonomous valet parking. So here's a case where, imagine that, maybe you do rent a car, or maybe this is your own car. You and your family want to get dropped off at a restaurant. You want the vehicle goes and parks itself. At the end of dinner, you command or you summon the vehicle back to pick you up, and you head off home. Or if you're out of town, it takes you to your hotel, and you can start to knit those kind of capabilities together. This does not, you think of it, of that vehicle's driving itself, so it's a level 4 or level 5 autonomous vehicle. Doesn't necessarily have to be that way. There's also some trials going on now of using a car in a drive-by-wire mode to go through kind of a corridor to a specific parking area that the restaurant might have. So it doesn't necessarily require autonomous cars to make this kind of use case initially happen. But if it does, and that's kind of the direction, it uses these technologies that you see at the bottom. It uses V2X, navigation and location-based services, autonomous driving, and of course, and machine learning and big data. But also, of course, underpinning all of this is data privacy and cybersecurity. So that's one particular example that's quite popular, that leverages autonomous driving. Here's another concept car that we've developed. This has been done in conjunction with a number of clients, and that in a consortium where the idea was to say, it started off as the idea that I want to develop a 3-wheeler for dense transportation marketplaces that can be autonomous. And then, the notion emerged to use this as a commerce platform. Well, what if I could use this for autonomous delivery as well? How could I do something like that? And so this actually serves dual purpose. It supports both of those. It incorporates 5G connectivity, obviously autonomous driving, and then it is connected to the cloud for offload. So some of the intelligence or some of the computations done in the cloud, the non-latency critical portions. But for latency critical portions, the other thing that was done here in conjunction with people like Deutsche Telekom was to incorporate edge compute servers that the vehicle could talk to that would orchestrate one or more of these units and provide low latency. And originally that was a test concept, but we've even seen in cases like, for example, in agriculture, let's say you had autonomous vehicles in agriculture and you were doing, harvesting. So you've got multiple autonomous vehicles, but I need some way of orchestrating. And, I don't know, this field that well, but I do know that as you're harvesting along, you get to the point where you have these balers or these trucks, and you're filling these up, and then you need to ultimately, bring in a new truck now and start to fill it up, et cetera. So you kind of get a chain of these going along in conjunction with harvesters. All of that can be autonomously orchestrated, but you need reasonable edge compute resources, and you might not be close to any type of macro cell to do so. So you install an edge compute server, and now you have this set of autonomous vehicles that are orchestrated by that edge compute server. This similar concepts being demonstrated here using this ensconce edge compute capability. So there's a synergy again between these technologies. Okay, and then the last one I'll cover under autonomous is an example that, let's say you have a truck fleet, and how do I now manage this truck fleet? Well, if manually driven trucks break down, then of course autonomous trucks are going to break down. So how do I remotely monitor and manage and maintain autonomous trucks? So I have to have a way of orchestrating and observing. So basically I'll have a series of sensors on board the truck itself that's going to monitor, again, same thing that helps you with predictive maintenance, but I'm going to monitor the state of the truck, temperature, pressure levels, et cetera, vibration, all of these kind of factors, as well as the software. And if I detect a fault, I need to do a safe stop and pull that vehicle over. I'll diagnose that particular vehicle. And then I need to send a patch potentially to the vehicle to repair it. Or if I can't, then I have to signal for a repairman to, a mechanic to go out and look at the vehicle itself. But I want to try and manage this as much from an operations center as I possibly can. This is happening. First phases of this have been out, and then subsequent phases are emerging. To facilitate something like that, we need to change the architecture of these types of vehicles. Vehicles today are defined by hundreds of isolated ECUs or electronic control units that are sitting around in different areas of the vehicle. Some of them are isolated on this CAN bus in some areas, but it's not very accessible. I can't program, I can't observe these things very well. They're not very scalable. So the trend, of course, is to move to a centralized compute platform where I can aggregate, I have sensors and actuators that I can aggregate. I have buses that then communicate to centralized computers. It starts to look a lot more like a data center, in terms of how it's structured, or a network in terms of how it's structured. So that's the next component. And then the last component that you start to see is, how do I program these things? So if I can begin to, again, if it was really complicated to program these embedded isolated ECUs, and I've now solved that problem with more centralized compute structure, I can now move to apply a DevOps or a DevSecOps approach to programming my entire end-to-end use case. I can program the vehicle that way, I can program the network that way, I can program the cloud that way, and now coordinate these things. So as you all probably know, for the past 15, 20 years, we've been migrating on networks to software-defined networks and virtualization of network components. Likewise, the cloud, of course, it now runs in containerized, virtualized functions that are scalable and uses a continuous, integration, continuous deployment, CI/CD kind of flow, relying on DevOps. What's been missing is, over on the left-hand side, that the same approaches haven't been applied in the embedded world. But now that's changing, because once it does change, I can program end-to-end use cases using a DevSecOps flow. And so all of these things, kind of down here, you see this micro service-oriented architecture. Basically, each of these are kind of going to architectures that now allow common layers of software-defined X. So software-defined vehicle, software-defined network, software-defined cloud. So that's a third trend that we see in enabling this kind of connected mobility services for autonomous vehicles. I'll skip this chart. You guys can view it on your own. It shows some particular standards that are used. But on the autonomous side, I'll conclude with just a summary of how, here's a specific example of aggregating over 30 sensors that are generating, in this case, about 35 terabytes per car per day, coming into a vehicle. And it has 3, what we call sensor fusion ECUs, or these electronic control units, over Ethernet. Things are moving more and more to gigabit Ethernet, again, starting to look more like a data center. And then has a telematics control unit that then pipes all of this stuff up to the cloud. So that's a specific architecture, and you start to see that this is moving more and more and more towards these, away from these isolated ECUs, towards consolidated, and more towards kind of like a data center on wheels. So, okay, last case would be the smart city interaction. So smart cities provide a rich blank canvas almost for the application of connected mobility services because of the importance of transportation in the smart city. So let's kind of go on, let's go ahead, Dan, and to the next slide. Yeah, exactly, and build it out. We see that, yeah, no, you can go ahead and skip ahead. So if you start to take a look at how is the smart city starting to think or be architected, on the right-hand side, you have your traditional data center and cloud, network core, then network edge. And the network edge might be cellular, it could be satellite, could be, fixed wireline, optical, whatever way you're getting into the data center or out of the data center. But then at what some people here calls it on-prem or outdoor edge. So on-premise would be kind of enterprise or outdoor edge, or some people had called this the fog. Cisco used to refer to this as the fog. Here you start to see some very interesting use cases emerge, like traffic management, security and surveillance can be used in traffic management, on-premise equipment, for example, to manage factories, this notion of Industry 4.0, Air quality monitoring is an example. Wireless access. This could be for instance, like CBRS, the public EMS channel support, for example, for first responders. There's a large variety of services that are connected services that are starting to emerge here at the smart city. You could create a roadmap like this for any kind of enterprise. This could apply to factories, could apply to oil and mining, could apply to a variety of different areas. And then you get to these endpoints, and this is where the action, of course, really happens to the user, which is, we talked about transportation, we talked about manufacturing, healthcare, and I'll give you an example here in just a moment that's pretty exciting. Drones for both last mile delivery, retail, certainly in the retail experience, entertainment, and a variety of other applications. So this is the network architecture for the smart city that's emerging. And notice how it will synergize with the architecture for these connected vehicles. So let's go into a specific example. Here's an example of a connected ambulance. And so it turns out, and this was prototyped in Spain, but imagine that the goal here was initially to improve operational efficiency of ambulance services by 10 to 20%. And here is my cat. So of say 10 to 20%. But now we ran this pilot, and it was between the Red Cross and a neurological hospital. And it turns out, because of regulatory requirements, you have to triage a patient to figure out if they should go to a specialty hospital, like a neurological hospital. Otherwise, they will just go to a general hospital, a general ER. And they were observing that that becomes a problem if there's neurological damage, spinal or brain or otherwise. And so in this particular case, what we did is, and let me explain on the right-hand side, we equipped an ambulance with a hotspot that would provide AR/VR support for the paramedic. So the paramedic is now, and at the other end of that, through the 5G access, is the hospital, where they're obviously able to see whatever the paramedic sees down here at the lower right-hand corner. And they're also getting through IoT all of the telemetry data, the biometric data about the patient, the vital signs, et cetera. So with that information, a triage doctor is able to triage the patient and determine, is this a candidate for the neurological hospital or whatever are the best facilities that patient should be routed to. They give instructions to the paramedic in addition to observing. And often sometimes there's even low grade procedures that they can instruct the paramedic to perform. I mean, this is not getting to that notion of telesurgery yet. But what they observed from this was an improvement in survivability of over 10%. They're projecting that as this gets better, it could probably be in the range of 20% for neurological cases. The other thing, though, they observed is that it provides more efficiency, but they can also use this same approach with a remote expert to actually train EMTs in the field. So the EMTs, of course, go through extensive training, but this becomes a way of like having a remote expert paramedic jump in and kind of coach EMTs. And so what they noticed is, they provided a much faster training ramp and a higher level of proficiency from the EMTs. And then they also determined that they're utilizing their medical resources much more efficiently. And these are the technologies that obviously I used below. It was 5G based, did use some local edge compute in the vehicle to support the rendering offload for the AR VR headsets, which are down here. And then of course it generated a ton of data. The machine learning at this point was a little limited, but it's mostly the remote expert support with a digital twin. But there'll be more opportunities to detect certain patterns. And then of course it's predicated on data privacy and security. Okay, I think we might. I don't know if we're out of time yet, but do we have time for one more case?
I think we do.
Okay. So this last case is an example of making our intersections smarter and thereby connecting intersections together to make a city smarter. So here, we understand that these autonomous vehicles are incorporating camera, LiDAR, radar onto a vehicle. In this particular case, what's being done is if you look in the upper right-hand corner, you see this kind of cloud edge server at the intersection. Well, what that thing contains is shown down below. It has an edge compute platform, which would be, think of it as, an Intel or otherwise, based edge compute node or server. It then has 5G, 4G access, and potentially V2X access. And then it also has, traffic management, functions here in the platform itself. And that includes the interfaces to, if you'll notice, it itself has camera and LiDAR sensors installed in it. So it's actually doing computer vision processing of what it sees around the intersection. So with that, it can then, in this application area, using video analytics, V2X, traffic management, it can orchestrate the traffic of that intersection. For example, if it detects this cyclist that is about to run through the intersection and might run into a car, it detects that. And that with appropriately equipped vehicles, as they start to incorporate V2X, it can send a stop basic safety command to the vehicle itself to avoid that type of collision. Same thing with a pedestrian, et cetera. So the notion is it's called cooperative perception. It's basically providing a better better vision to see around corners, to see through cars in front of you, to have a better awareness. And again, this notion of cooperative perception in the city itself. So it seems pretty sophisticated. It is, but it is being deployed in trials in a number of different cities today, both in the US and Europe and in some other countries. Okay. And there's,
yeah, there's a couple more, but I think that really was a great example of a lot of these technologies. And Scott, what we started off talking about was a lot of these technologies are coming together and meshing together exactly how you described and defined in your use cases. So I think everybody probably has a really good idea now of how these things are mapping overlaid onto each other to produce these kind of capabilities that are really very exciting. Shannon, do we have a second to maybe open up to some questions if there are, or comments? Would that be okay?
Absolutely.
Excellent.
Yeah, I suppose I have one. So when it comes to the technologies used to solve problems, how do you go about selecting them? Are they Capgemini led or client led, or?
They are actually both. So I'll give you an example, and this is public information. We have a partnership with Intel on exactly this kind of use case where Intel came to us and said, okay, Capgemini, you have a big business in automotive, and you also have a big business in communications. We need to do a program around edge compute in cities, in smart cities and other transportation corridors. So we would like you to build a platform that you could then go to your other OEMs, with. And so that in that particular case, it's partnership led in that particular direction to look for opportunities where that solution would make sense. In other cases, though, a client will ask us to evaluate. In fact, Dan and I have talked about this a lot. If we start to look at use case ideation, it centers around your business problem, what business problem you're trying to solve. And that's where the Invent team does an amazing job of kind of walking you through and helping to identify that. They then work with us on the technology side to look at a menu of technology options that work for you. And some clients have a clean slate for doing that. Others have certain preferred vendors that they would prefer to see involved in that in their ecosystem. So we do work in kind of both models. So does that kind of give you a flavor for it?
Yeah, thank you. That was a great presentation, by the way, from both of you.
Thank you.
Good, thanks.
Well, I'll just add just one comment to that, because we're trying to find solutions and technologies that solve a business problem, which I think is absolutely critical. But also, there's this idea of what is supporting the brand. So like all the OEMs are still going to be OEMs. They're still going to have a brand foundation that these also have to support, address, and extend in many ways. So, you know, it's not going to be just the everybody has a box that drives itself. There are going to be unique properties to each one of these OEMs that we have to tease out and do that in the way that we integrate these technologies that we're using. Shannon, do we have any more questions? I've got a question for Scott if nobody else does.
Well, I had a question.
Oh, cool. Please.
Yeah, I'm just wondering, you know, you talk about level 4 autonomous vehicles. Is there a time frame on, you know, when can my car go and park itself?
Well, I think, you know, what was it, 2 years ago, Elon Musk said he would have L3 autonomy out that year. And, you know, it's just now coming out, right? And it still, you know, they're still working out some things. I heard when we started looking at what problems to solve on autonomy, it really depends on the level of autonomy one's trying to achieve. If you're just, for example, on a highway, you know, and you have autopilot mode and you're looking at entrance to exit ramp on the highway, that's a pretty solvable problem today. So I think, you know, you see that emerging today. This notion of, you know, garage to garage, however, is much more challenging. Add to that, and that's just because of the random nature of things that run out in front of you. The other big one that, you know, they're still trying to work with is, you know, I know in my town, they're changing they're doing road construction on the highway. So right now it's confusing even for me to know where my lane is. And as you probably know, there were some Tesla crashes related to that it couldn't detect exactly where the lane was. The other one is the weather. The level at which an autonomous vehicle can operate based on you know, the SAE levels is predicated on the weather. So what happens suddenly if the weather changes? You know, you get icy rain or something like that, sleet. Now you have to deprecate the level of autonomy you can operate at. There's not yet a standard for communicating that kind of weather data. So I think it's going to be incremental. What we now see, though, is commercial applications of autonomy are very strong. Commercial long-haul trucking. I saw an interesting presentation, by the way, that said it's not going to replace truckers. There actually will still be an increased need for truckers, but long haul will be autonomous. Local will be manual. You know, truckers may not have to be away for weeks and weeks and weeks, but they'll still actually need more of them. So that use case is definitely taking off. There's also campus shuttles and hospital shuttles and things like that. You're starting to see those be more autonomous. So I think the commercial applications, you know, you think of mining and construction and other areas like that where safety is important and efficiency is important. It seems like, and I, you know, I could be wrong, it's more, at least in terms of our activities, those kind of tailored industrial use cases seem to be emerging right now. So I guess I had a long-winded way of not answering your question exactly. But.
Well, I know in the third quarter earnings call for Caterpillar, Jim Umbleby, who's the CEO, talked about, you know, the conversations with the mining customers. And by the way, mining has been filling the pipeline for the next 2 years, which is awesome. But the conversation has gotten away from how do you cut costs and help them, you know, be more efficient, to all the conversations now are about autonomy. And Jim, I think, talked about there's 100 autonomous mining vehicles out there today, and the plan is to get to 400. I don't know if that's in the next year. I can't remember the time frame, but in short order. So
that makes a lot of sense. it's a controlled use case too. You guys know it very well. So you can bound the problem, a bit better, and you don't have to deal with a consumer. You could train operators,
Absolutely. Well, this has been excellent. I think, Daniel, you said you had another question? Or
I do. I have a wild card question for Scott. So I've been seeing a lot about computer vision, and it seems to be super hot right now. What do you think is the super hot technology that you see coming like just over the horizon? What do you think is really going to have a big impact next?
You're absolutely right on computer vision, training for, machine learning. If you look at this, the whole notion of reconstruction, I think one of the things that we see in that realm, just to stay on that topic for a second, is this notion of digital twins. I think that, which does actually leverage computer vision. If you think about this notion of building a virtual world, and that virtual world becomes a good representation of ground truth, then now once you have that virtual representation, you can do a lot. So I think digital twin is a huge emerging area. Some experts in that area might tell me, oh, that's not the future, that's now. Right. It always depends. The future is always the present in some other context, but I think digital twin's huge.
Yeah. The future is now, just not evenly distributed.
That's the quote. Yeah.
Excellent. Well, Shannon, thank you so much for having us this evening. I hope that was an interesting run through a couple of topics. Scott, thank you so much for joining. You jumped in just in time to make those slides much more meaningful and data rich. So I really appreciate it. And again, Shannon, thank you so much for having us tonight.
Hey, you guys.
Yeah, thanks so much, Shannon. I really appreciate the hospitality.
Yeah,
thank you very much.
Very much enjoyed having you guys here. I was trying to recruit a different Scott online, Scott Farr, to speak for you, Scott. But
I wouldn't have done it justice, Shannon.
Hey, we're all one team, and again, my apologies for being late. I'm just glad I was able to time it.
Perfect.
Likewise.
Timing.
Yeah, perfect. Thanks to Scott and Daniel. I appreciate that very much.
Absolutely.
Outstanding job.
Appreciate the questions too.
All right. Shannon, we'll be back in touch, and thanks to everyone who joined us. We really appreciate it.
Hey, one last question, just real quick. If somebody wants to get a hold of you and they have more questions, or they, want to find out more about your company, where do they go? Who do they contact?
You have my contact information, so if they want to reach to you, they can just filter it through me, whatever we want to do that way. It's totally fine.
Happy to do that.
Yeah, we didn't really spend any time about the company. We wanted to focus on the topic, but yeah, you're right. We would love to be able to share that with you.
Okay. Well, I am recording this. I am going to post it out there on the meetup. I'll also see if I can post it out on the LinkedIn event. I just want to thank everybody that participated today. Great conversation. I think this was, an excellent meetup, and one that worked, I think, very well virtually. So great topic, guys. Thank you very much. And we will have our next meetup. It's going to be November 20th. The last Thursday before Thanksgiving. I believe it's the 20th, 19th. But thank you guys very much. And you guys all have a great rest of your evening.
Likewise. Thank you.
Thanks,
Bye-bye.
Thanks,
Likewise.
everybody.
Bye.
Thank you.